right, so this is section 8.1, system of linear equations. You've solved most of what we're going to talk about today in Algebra 1. Most likely in Algebra 1 Part B is when we talk about systems. And so systems are where you have multiple equations and two or more variables, and you're trying to solve the two equations that you have for two variables. So for example, if you're working with systems, if you have two variables, you have to have two equations in order to solve. If you have three variables, you have to have three equations in order to solve. If you have four variables, you have to have four, and so on and so forth. So the more missing pieces of information, the more variables you have, the more systems you have to have. All right, so when you're solving systems of equations, there are three possible outcomes here. The first possible outcome is that maybe you have two lines and you're trying to figure out their intersection point. And either the two lines intersect, which means that your solution would be a coordinate point, an x and a y, x being one of the variables, y being the other, and that would be your two solutions, one for x, one for y. You can list it as a single coordinate point. Option number two, the two lines are parallel, and parallel means that they never intersect, and so a solution does not exist, which means if you end up with two parallel lines, there is no solution there. They're never going to cross. And then your third option is that you have two lines, but they're the same line. And so you'd have a line here, and then if you were to draw the second line, it would literally draw directly over top of the other line. They're the same line. They just have an equation that's written in two different ways. So maybe one of them has a GCF or something like that. And your solution in this case is everything. Everything would be your solution here. All x's and y coordinate pairs would be the solutions. And so you could say all real numbers there would be solutions. All right, when you're solving these, you are looking, these are your three possibilities of your outcomes. And there are three ways that you can solve. The first way is you can solve them by graphing. Take a look at their graphs, figure out where they intersect. All right, so we're going to graph both of these, and then we are going to place a dot at the solution, and I'm going to write the solution point as well. So the first graph is in slope-intercept form. So it starts at +4, and its slope is -2, and that'll be over 1. And so here is my line. There we go. All right, the second line starts at -12. You can't really see that down here, -12. And then it has a slope of 2 every time. So plotting the y-intercept and then going up and over might not be the easiest way to do this. And so we know that we're going to be kind of somewhere over here. So it really is kind of up to you what you want to do in order to try to get a picture of this graph. If you want to extend all the way down and draw and see what's going to happen, that's fine. If not, what you can do is you can kind of know that this line would head this direction. So maybe plug in 3, 4, and 5 and see where your coordinate points are. So if you plug in 3, this would be 2 times 3, which is 6, minus 12, which is -6. So at 3, you're at -6. And based off of that point, you can either use the slope to continue drawing the graph, or you could just plug in more points. So if you wanted to plug in 4, you could plug in 4 and see what happens. We're going to use the slope. So from there, the slope is 2. So it goes up 2, 1, 2, and over 1, and then up 2, over 1. So your line is coming in like this. So this point right here would be your solution point. And it happens when x is 4, y is -4. So for both equations, if you plug in 4 for x, your y value will be -4 for both of them. And that's what makes it a solution. All right, the next option you can do is use something called substitution. Substitution is where you replace one variable with the equivalent variable in the other one. So in this problem, we're going to substitute y. And so in this first equation, where the y equals 2x plus 1, I'm going to take out this y, and I'm going to replace it with what y equals here. So I'm going to replace it with negative x minus 5. And so we would set this up as negative x minus 5 equals 2x plus 1. And then from there, you can go ahead and keep solving this. This is just a linear, right? Nothing too crazy there to solve. So we would add x and subtract 1. So I'm going to say negative 6 equals 3x, which means x is equal to negative 2. And then you do have to find the y as well, because remember, these are the solution points. So you're going to have to tell me both the x and the y coordinate. And so to find the y, it's really easy. Just plug negative 2 into either one. Completely up to you, because they'll both give you the same y value. So I'm going to plug it into the first one. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. So your coordinate point, your solution where these two lines cross, is at negative 2, negative 3. All right. We have one more solution problem for you, or solution substitution problem for you. This one's a little bit more complicated. And so we're going to have to substitute in some variables here. So either you can solve for y and plug in y, or you could try to solve for x and plug in x. Based off of this second equation, I think the easiest thing to do would be to solve for y, because this is almost y equals. It's super close. So if we get rid of that negative and we make the adjustment over here as necessary, then this y will replace this y, and you replace it with what y is equal to. All right, so if I want to do this, I can divide by negative 1, right? And if you do that, you have to divide everything over here by negative 1. So this equation really is y equals 2x plus 3. And so what we're going to do is we're going to take the y in the original, the first equation. We're going to get rid of it, and we're going to replace it with this y. Well, this y is equal to 2x plus 3. So we're going to put 2x plus 3 right there. So we have 2x plus 3, and then continuing minus 2x equals 3. All right, combining like terms, 2x minus 2x is 0 x's, so you don't have to put those down anymore. And so you do have 3 on this side equal to 3 on this side. And so this is one of our special, let me find that page. This is one of our special outcomes. So it's not the one where they intersect. It's either the one where they're parallel or where they're the exact same line. So it's one or the other. And so because we have 3 equals 3, that is a true statement, isn't it? That's true. 3 does equal 3. And so because that's true, what that means is that it doesn't matter what x value you plug in, you're always going to end up with a true statement. So this situation is where the lines are the same. It was the exact same line, just written in 2 different ways. So these lines, if we were to have graphed them, it would have been the same line graphed over itself. And so because it's true, then your solution is all real numbers. Any x value you plug in will work. All right, so the next method, we talked about graphing, we talked about substitution. The next one is elimination, or some people like to call it the addition method. I like to call it the elimination method, because what we're going to do is we're going to eliminate a variable. And this is probably the most common method that you're going to see. We're pretty much going to use this method for the rest of our notes today. And so just lots and lots and lots of elimination from here on out. So when you're looking at this, when you do elimination, you want the equations to be set up so they look pretty much the same. You see how it's something x plus y equals a number. X plus y equals a number, right? Where over here, it wasn't set up like that at all originally. It was y equals, and this was y minus x equals. And so you're going to want to make sure it's set up. This is what we call in standard form. All right, and so we're going to want to eliminate a variable here. You're going to eliminate the variable by adding these two equations together. So essentially what we're going to do is we're going to draw a line and add the equations. And when we add the equations, we want one of the variables to simplify out with the other variable. So for example, here on the y's, you have y and then you have y, and they're both positive. So if you were to add these equations together, you would end up with 2y. But if one was positive and one was negative, you would end up with 0 y's, and the y's would be eliminated. You could also do it with the x's. If you add them together right now, you would end up with negative 4x. But if you had a 5 here, then when you added them together, you would end up with 0 x's, and the x's would be eliminated. It doesn't matter which variable you eliminate. Sometimes one will be easier than the others. But in any case, you just pick one, whatever one's easiest, and you eliminate it. So let's go ahead and let's eliminate the y, because that was just a sign change, right? So what we're going to do is we're going to take this equation and we're going to multiply everything by a -1. As long as you multiply the entire equation, both sides, you haven't changed it. And so what you're going to have here is you're going to have a -x, a -y equal to a -5. And that equation is the same as the original. And so we're going to ignore this equation now, and we're going to add those two equations together, the first one and the second one, and we're going to see what we get. -5x minus x would be -6x. The y minus the y is going to be 0 y's, and so we have eliminated the y's, equals 17 minus 15, which is 12. And so when you eliminate a variable, you are left with a single variable equation that is really easy to solve, right? You just divide by -6 and you have x equals -2. So we know the x coordinate of this point where they cross. And so now we have to go find the y. You can use any equation that you want. You can use your original, the first one, the original second one. You can use any of the ones that maybe you've made some changes to. Any equation you want, plug in x, and it will help you find the y. I'm just going to use that first one since I didn't cross anything off. So if I plug in -2, I'll have 10 plus y equals 17. And subtract 10 from both sides, I have y equals 7. So your coordinate point, your solution here, the x value is -2 and the y value is 7. All right, let's see another elimination problem. This one looks a little bit more complicated because we have some fractions. Don't let the fractions get you all mixed up though, right? Just fractions. And then if you notice, this one is written backwards, right? Your 3 and your y is backwards. So we're going to probably have to do some changing of a bunch of equations here. I don't know about you, but I'd rather not work in fractions, right? So if you'd rather not work in fractions, we can take that first equation and multiply it by a number to get rid of the fractions. And so if this is 1/2 and this is 1/3, the best number to multiply would be 6 because 6 has both a 2 and a 3 in it, and then that's going to get rid of all of our fractions. All right, so this first equation, I'm just going to draw an arrow. It's coming this way. 6 times 1/2 is 3, so we have 3x. 6 times 1/3 is 2, and that's a -2y. And then 6 times -1 is -6. Don't forget you have to multiply every single thing in the equation in order to not change it. All right, I'm going to rearrange this bottom one here. So I'm going to bring it this way as well. And I'm going to put the x in the front and then the y second. And then I have equal to that number. All right, checking out these two. So now I'm not going to use these equations anymore. I'm going to use the ones that I've made some changes to, and they look a lot better. Eliminating a variable. Well, right now I can eliminate the x by just adding them together. I also can eliminate the y by just adding them together. So let's see what happens. We're just going to go ahead and add these equations. We'd end up with 0x and 0y. So that side is 0 equals negative 6 plus 6, which is also 0. And so guess what? We are back to one of our special outcomes. It's not one where we have a coordinate point. It's either no solutions or everything. And because this is 0 equals 0, that is a true statement. And so the answer is everything. All real numbers. If you had like 0 equals 1, that would be a false statement, right? 0 is never equal to 1. And what would happen there would be they would be parallel in that case, and that's where you would have no solution. So if you want to go back to this one, and you want to say you have like a true, so if you have a false statement like 0 equals 1, they're going to be parallel. If you have a true statement like 0 equals 0, then they're going to be the same line. So if you want to update your notes real fast so that you can recognize what's going to happen as you're solving, that might not be a bad idea. All right. From here on out, we're getting into some story problems. And so the main thing here is you just have to try to figure out how to set up these equations. When you get them all set up, then you're pretty much good to go. All right, so it says the sum of two numbers is 60. So our two numbers, we don't know what they are, so we're going to say x and y for our two numbers. Their sum is 60, so x plus y equals 60. The difference between the two numbers, difference is subtract, so x minus y is 22. And it says, what are the two numbers? So here's what I'm going to do. I helped you with the setup, so you have your two equations. I'm going to pause, and I'm going to let you practice seeing if you can solve and figure out what the two numbers are. What's x, what's y? What are the two numbers? Once you have them, we'll pause this video. Once you have them, you can hit play, and we'll go through and make sure you got them real fast, and then we will continue on. All right, so here is the solution for that problem. So you were good to go ahead and just add your two equations together. It eliminated the y, so x, you just divide, you get 41, and then you can use either of the two equations to go back and figure out what the y was. So y has to be 19. So your two numbers are 41 and 19. All right, so we are going to do a couple more story problems. They get a little bit more complicated as we go through. And so the hardest part about these will be setting up the equations for sure. Once you have the equation set up, though, it's just the elimination process every single time. All right, so a bank loaned out $19,000. Part of it at a rate at 11% annual interest, and the rest was 7% interest. The interest earned for both loans was $1,750. How much was loaned out at each rate? So you have to think about the bank. They have essentially two loans that make up this $19,000, right? They have one at 11%. They have one at 7%. And so that's where our two equations come from, our two variables there. One at the 11 and then one at the 7. And so what we know is together it was 19,000. So our two variables, x plus y, have to add up to be $19,000. X amount of dollars in one and y amount of dollars for the other. So $19,000 total. The second equation is based off of the interest numbers. So the x, I'm going to let be the 11% interest. And so you can calculate its interest by doing the amount times 0.11, right? 0.11 for the percent. And then for the other interest rate, 0.07, that's going to be the y. And you can calculate its interest by doing 0.07 times y. And if you add the interest from both of the amounts, the total interest is $1,750. And so writing those two equations was a little bit more complicated. Most likely, this one would probably be the easiest because that's where all of the values come from. However, this one is actually really the easiest, isn't it? But we kind of forget about this first one in terms of both amounts have to add up to be 19,000. I know there's decimals. You can use your calculator, and you're going to solve it just like you solved any of the other elimination problems. So you can either multiply the first equation, multiply the second equation. I'm actually, in this case, I think it's easier to multiply that first equation. And so if you take that first equation, I'm going to get rid of the x just because it's in the front, and you could get rid of the y. It really doesn't matter, right? You can do either one. And so if I have a negative 0.11 here, then that x will be eliminated. So I'm going to multiply that entire equation by negative 0.11. And here's what I'm going to get. I'm going to get negative 0.11x minus 0.11y, and then 19,000 times 0.11. And you can use your calculator, right, to go ahead and calculate that value, negative 2,090. And so that is that first equation rewritten. So I'm going to add these two equations together. So the x's are eliminated. Adding the y's, we get negative 0.04y. And then adding these together, we get negative 340. And then it's just a simple division. So y is going to be $8,500. So in the 7% account, remember y was based off the 7% account. In the 7% account, you're putting, they're loaning out $8,500. And then you do have to say, well, how much went into the other account? The easiest way to figure this out is to go back to x plus y is 19,000. So just 19,000 minus 8,500 is 10,500. So this was at 7%, and then this one was at 11%. So as you put them in, you have to make sure you get them in the right spots. So a little bit harder on the setup, I think. The solving, I wasn't too bad, really just some decimals. But yeah, definitely that setup a little bit more complicated. All right, and this is probably the hardest setup that you're going to see in this homework section. There's a lot going on here. So a man flies a small plane from Fargo to Bismarck, North Dakota, a distance of 180 miles. Because he's flying into a headwind, the trip takes him 2 hours. So on the way there, it's 2 hours. On the way back, the wind is still blowing at the same speed, so the return trip only takes an hour and 12 minutes. So on the way there, he's going against the wind. On the way back, the wind is helping him out. What is his speed in still air, and how fast is the wind blowing? So when it says his speed in still air, it's saying how fast is he going, and then how fast is the wind blowing. All right, and so before we can set up these equations, there is one relationship that you have to know, and this is what makes it a little bit harder, is you have to know the relationship that distance is equal to the rate times the time. And so you can mess with this equation, and you can say that your rate is equal to your distance over time, right? You can just go ahead and divide by t. And so we're going to use the fact that the rate, that's his speed, right, is equal to the distance he travels divided by the amount of time it takes him to get there. So on the way there, he has his speed, right? I'm going to, instead of using x and y, I'm going to change my variables to help me out a little bit here. So that's his speed. And the wind is working against him, right? Against him. So because the wind is working against him, we're going to subtract how fast the wind is blowing. And that will give us his rate. So it's his speed minus how fast the wind is blowing because it's working against him. That'll give us the rate. And then this will be equal to the distance, which is 180 miles, over the time it takes him to get there, which is 2 hours. On the way back, he's traveling at the same speed, so same S. But this time the wind is working with him, so he's going to be going faster. So we're going to add the speed of the wind. And then he's still going 180 miles, but this time it takes him an hour and 12 minutes. And so 12 minutes in terms of an hour, 12 divided by 60 is 0.2. So it's 1.2 hours. So make sure if it tells you like hours, minutes, you put them all in the same units. And since this was all in hours, I want this one to be in hours. So 1.2 hours. All right, so those are equations, and we can simplify them a little bit. So this would be S minus W equals 90. And then this would be S plus W equals, let's calculate that real fast, 150. And so you can go ahead and solve these with elimination. So hit pause on the video, solve them. You shouldn't have any issues here, right? Solve away, and then hit play again, and we'll go back to his speed and the speed of the wind. All right, so you should already have this problem done, right? You should have added these together and get 2S equals 240. So his speed is 120, and this would be in miles per hour. And then the wind speed, and you can use either of your equations. You can use either these two or these two, any one of the four you want. I'm going to pick this one because I think that's the easiest. So what do I have to add to get 150? Well, you have to add 30. So the speed of the wind is 30 miles per hour. All right, so this problem, once you had the equations set up, they actually weren't hard to solve. However, the setup of these equations is quite difficult as well. So as you're working through these homework problems, if you're struggling and you're not getting the right solutions, it could be your setup of equations. So if you reach out for help, make sure you tell me what your initial equations were, because that's what I'm going to ask for first. I'm like, well, what equations did you use to make sure that you have them set up? If you need help setting up an equation, just holler. I will help you set them up. All right. These last two are still systems of linear equations, but these ones are systems with 3 variables. So instead of 2 variables here, we have 3. We have x, y, and z. And so we're going to solve these systems using algebra. And yeah, there's going to be a lot of algebra associated with this because now we're finding 3 variables as opposed to just 2. So elimination is most likely going to be your best bet here. If you notice this bottom equation, I'm going to label them for reference. You have equation 1, equation 2, and equation 3. All right, just for reference, make it easy so we know which one I'm talking about. So equation 3 doesn't have an x, does it? And so this one's going to be useful if we want to solve for y or for z. Equation 1 and 2 have all 3 of them. So the strategy here is to use equation 1 and equation 2 and to eliminate the x, because when you eliminate the x, you're going to have just a y and a z left. And then you're going to use that equation with the third one, which is just y and z, to eliminate either y or z and give you just one variable. So the first one you're going to work with is 1 and 2, and you're going to eliminate x. You're not just going to eliminate one of them. We're eliminating x on purpose because that third equation does not have an x. So to do that, I'm going to go ahead and take that top equation, the first one, and multiply it by -2. So here's what I have. I have -4x plus 2y minus 2z equals +2. The second equation, I'm not going to change. I'm just going to rewrite it here so I can see what I'm doing. And I'm going to go ahead and add those together, and my x's are going to be eliminated. So I'll have 5y plus 3z equals 3. And I'm going to call this now the fourth equation. So I used equation 1 and equation 2. I eliminated the x, and I got a new equation with 2 variables, and my variables are y and z. And so what I can do now is I can take that third equation that only has y and z, eliminate either y or z with this fourth equation here to get one of my variables. So now I'm using equation 3 and equation 4, and I'm going to eliminate something. So at first glance, I have 5y, 5y, 3z, 3z. Ooh, this will be interesting, won't it? So it doesn't matter which one you eliminate. Let's go for the y. So I'm going to multiply one of these equations by -1. So I'm going to go ahead and just multiply this equation by -1. So we'll have a -5y minus 3z equals -4. That comes from here, equation 3. Equation 4, from down here, I'm going to just leave this same. And I'm going to go ahead and do the elimination. So I eliminate the y's. I also eliminate the z's, which is interesting. So this side is equal to 0. Over here, I have a -1. And so this is one of our unique situations, right? It's not where we have a solution. It's either all of the numbers or none of the numbers. And so this is a false statement. 0 is not equal to -1. And so what that means is because that is false, there is no solution to this system. There is no value of x, y, and z where you can perform these operations and get these numbers. It's just not possible. If we didn't get both the variables to eliminate, we would have one variable left, right? We would have the z, and then you would just do a simple operation to solve for z, use that z in either one of these equations to solve for y, and then use the z and y in either one of your equations with 3 variables to solve for x. All right, so I am going to have you pause, and I'm going to see if you can do this one. This one's a little bit harder, but if you want to give it a shot, after we kind of briefly talked about this, if you want to see what you can come up with, then go for it. Hit pause. If you're like, I have absolutely no idea, then you can just leave it playing, and we're going to do this one together. But if you want to give it a shot, hit pause. When you unhit pause, then you'll see all of the work. All right, so I'm going to label these equations as 1, 2, 3 again, because that really does help us kind of keep them organized. And unlike the last one, all 3 equations have an x, y, and z, which is a bummer. But what we're going to do is we're going to eliminate some variables. So let's go ahead. I think that eliminating, I don't know, what should we eliminate? That y doesn't seem too bad. Look, if you go ahead and do these ones, that's not a bad elimination for y, I think. So we're going to start by eliminating y. Doesn't matter which one you want to start with, but I just think y is going to be the easiest. So we're going to eliminate y. So the first thing we're going to do is equation 1 and equation 2. And so when you put equation 1 and equation 2 together, you're going to have x plus y plus z equals 3. That's equation 1. 2x minus y plus z. That's equation 2. And when you put them together, you'll have 3x. The y's will eliminate. Plus 2z equals 5. And so we can call this equation 4. And so we have an equation now that has x and z in it. And so what we're going to do is we're going to eliminate y again with a different set of equations, and so that we have one more equation that is an x and z, and then we'll use those two to eliminate the last variable. All right, so I'm going to eliminate y again. This time I'm going to use equation 2 and equation 3. You could use 1 and 3 or 2 and 3. It doesn't matter, completely up to you. I just picked 2 and 3 because they're right here next to each other. In order to eliminate the y, you have to eliminate y still. In order to eliminate the y, this equation here, you should multiply by 5, right? To get negative 5y and positive 5y. So if you multiply it by 5, you'll have 10x minus 5y plus 5z equals 0. And then the third equation is negative 3x plus 5y plus 7z. Don't change that one at all. Is equal to 7. All right, putting those equations together, you have 7x, the y's are eliminated, plus 12z equals 7. And we're going to call this equation 5. So we put 1 and 2 together by eliminating y, and we got a new equation with just x and z. We put 2 and 3 together, eliminated y again to get another equation with just x and z. And so now you're going to use this equation 4 and equation 5 to eliminate another variable. And I think we'll want to eliminate z for this one, won't we? That'll be easier. And so we're going to do 4 and 5. Equation 4, equation 5 will eliminate z. So in order to get the z's to go away, I have 12. So this needs to be a negative 12. So I have to multiply by negative 6. So we'll have negative 18x minus 12z equals negative 30. Right? Times by negative 6, negative 6, negative 6. And then 7x plus 12z equals 7. And this will eliminate the z's, so we'll have negative 11x equals negative 23. So that would mean x is a decimal, right? I'm pausing because that's not what I got when I did it the first time. I didn't get a decimal for x. I think I figured out, maybe you noticed this as we were doing this problem, but I think I figured out where I made a mistake here. So just bear with me. When I did equation 1 plus equation 2, right here to eliminate the y, I put a 2 here equals 2 instead of equals 0. Just randomly, like literally I just randomly put a 2. Because we didn't multiply that equation at all. I just put equals 2 and then I added them together. So this should be a 3 instead of a 5. So if you caught up on that, if we were in class and this wasn't recording, you'd be like, wait, Miss Bird, hold on. But if not, yeah, I don't know what I did. I just randomly put a 2 instead of a 0. So when they add them together, you only get 3, which means that when we use this equation here and multiplied it by negative 6, we actually had negative 18, which means when we added 7, we ended up with negative 11, and that's a much better x value to be working with, right? So that means that x has to be equal to positive 1. Sorry about that. We all make mistakes, but if you get to a point where like something went wrong, this is a key. Don't erase everything, right? Just because you have something wrong doesn't mean the entire thing is wrong. Don't just go through and erase. See if you can go back and figure out, well, where might that mistake have happened? And so I just kind of ran through my numbers real fast and I was like, wait, that's a 0. Why don't I have 0? All right, using the x, you can now find the other variables, right? So because we know x, you either want to use equation 4 or equation 5 to find z. So either one, you would plug in x and find z. So I'm just going to use equation 4. So if I plug in 1 here, I would have 3. Subtract 3. 3 minus 3 is 0. 0 divided by the 2 is still 0. So that means that z is equal to 0. And then you can use x and z to find the y. So that's when you're going to go back to one of your original equations here. And probably this one would be the best, right? 1 plus y plus 0 has to be 3. So that means that y has to be 2. So here's your solution. When x is 1, y is 2, and z is 0, all of these equations will equal these values. As a coordinate point, you would put 1, 2, 0, x, y, z. It's a three-dimensional coordinate point. We don't talk much about the three-dimensional plane, really. We just talk about the XY plane. But there is technically, you could draw a z-axis on that plane, like going in and out of your paper. And that's where you would get that coordinate from. All right, so that is it for section 8.1. Let me know what questions you have, especially as you're working through your homework. If you're struggling to set some stuff up, please let me know. If you're working through some problems like this and you're not getting the right solutions, please don't erase everything. Please leave it on your paper before you're like, Miss Bird, will you help me? Because that will make my life a lot easier, all right? And yours, because then you don't have to redo everything. So please let me know how I can help you, all right?